Hi, welcome to our live chat. We've switched over now and we're going to talk about the biomedical engineering program. My name is Jamil Ahmed. I am the head of the Department of Biology and Biomedical Engineering. I've been teaching at Rose since 1999. A lot of what I teach is sort of freshman design. I've taught some systems analysis classes, uh, and I've taught a lot of physiology classes and a little bit of advanced design classes.
My name is Christine Buckley, and I also teach in the Biomedical Engineering Department. I have been at Rose-Hulman since 1994, so I think I win this contest, if being old is the contest. My area of expertise is in biomaterials, and particularly in orthopedic biomaterials. So I've studied the materials that are used especially for artificial hips and knees. But since I've been at Rose-Hulman, I've taught many courses in both the biomedical engineering department and in the mechanical engineering department too, in materials and mechanics. I teach our BE lab course in the junior year, and I've taught also in our junior and senior design sequence in the department.
All right, we can jump right in. Hannah would like to know if you could expand on what biomedical engineering encompasses.
Sure. So I can start and then maybe you can jump in later. Biomedical engineering is, first of all, it's an engineering degree. So if you're comparing it to others, you should probably compare it to like mechanical engineering or electrical engineering. But what we do is we take engineering skills and engineering analysis approaches and design approaches and apply them towards helping humans, right? Applying them to health, to disease, to treating disease, to helping people who have disabilities reach their potential. And so largely, most of our alumni probably work in the medical device field, working to build devices to help surgeons, to help healthcare professionals, to help people with disabilities function better.
Biomedical engineering is a very broad field. And so if I can simplify it a little bit, I sometimes think of it as, and this doesn't really encompass everything, but as a starting place. You can think of it as sort of in two bins. A big part of biomedical engineering takes ideas and concepts and skills from mechanical engineering and uses those to apply them to problems in health and medicine. So we take basic mechanics ideas and now we call it biomechanics, and we apply those mechanical principles to study of the way the human body moves, either in normal circumstances or in, where there are certain pathologies. And then the other sort of large category within biomedical engineering takes principles and ideas from electrical engineering and does the same thing, apply them to problems in medicine. And so under that umbrella, you see things like imaging. So MRI and CT scanning and ultrasound, that would all sort of fall into that category. There also are lots of devices that use electrical engineering principles and ideas. So things like implantable defibrillators and implantable muscle stimulation. You think about a prosthetic arm that uses electrical signals from muscle in order to control the arm. That's really sort of a crossover thing, right? So you're using electrical engineering principles to harness those electrical signals generated by muscle in the residual limb, and then using mechanical principles to drive this prosthetic limb. So it really, and what I've said just now is really just a simplification, but it's at least a good way, I think, a good framework to start thinking about all the different things that really fall under that biomedical engineering umbrella.
Great. For those of you that are, since none of you, I believe, are in Terre Haute, we're having a thunderstorm, so if you hear rumbling, that's what it is, and not a stampede. But Thomas actually has two questions here. I'll give them both to you, and you can kind of divvy them up as you see fit. But he'd like to know what kind of research is available for biomedical engineering students as soon as their freshman year, and what are typical senior research projects for biomedical engineers as well?
So there are a lot of things going on in the department, and I can talk about some of the things that sort of fall, because my expertise is kind of in the mechanical area. So we have an orthopedic biomechanics lab on campus that is a collaboration between researchers at Rose-Hulman and a group of orthopedic surgeons whose practice is in Indianapolis, who we have worked very closely with. And so this to me is the perfect embodiment of what biomedical engineering is all about and sort of how it was born. There are these surgeons who are treating patients on a daily basis, replacing their hips and knees, in particular in the case of the ones who we work with. And they have lots of questions about how to better treat their patients, and they don't have the technical skills, the research skills to answer those questions. And so they bring those questions from their clinical practice and say, you know, when I implant these tibial components in a knee replacement, I have the option as the surgeon of maybe implanting that tilted a little bit towards the outside of the leg, tilted a little bit towards the inside of the leg, but I don't really know what is the long-term effect of those surgical decisions that I make. So we can use our engineering equipment and our engineering expertise to help them answer those sorts of questions. So we have this lab on campus that has the capacity to do work with cadaveric limbs, and it has all sorts of mechanical testing equipment in there. And we have students in that lab who work directly with surgeons. They frequently get to go and watch surgery, in fact. And so those opportunities are some of the things that exist.
Yeah, and so there's also some other interesting projects going on. That's one of them. Dr. Dasmar on our campus is working to develop drug delivery systems. So what she does is she builds these microbeads that are filled with drug, and is modeling and is developing them and modeling how that you can implant those things to deliver drugs over a long period of time. She's had many students working on that project in different ways. Dr. Alan Chu does a lot of work in brain-machine interfaces, and so what he does is, so what that means is that you're able to take an electroencephalogram, an EEG, take signals out of that, extract it, and try to figure out what the person is trying to think, what the person is thinking about doing, and then turn those into actual commands. So he's had students build artificial arms, robotic arms that they can control by thinking about it. He's had students build a wheelchair that had some EEG, some brain-based control. And so with that stuff requires a lot of that's really advanced stuff. It requires advanced signal processing knowledge. So that's probably more geared towards the upper level students. But we've had students start in the freshman year, and the advantage of Rose-Hulman is that, you know, we're not a research factory, right? So we are designing research experiences that are specifically designed for undergraduates. And so what we can do is we can find, if you're a freshman that's interested in research, we say, come on in, let's find something that you can do. We've had students that have done that through 4 years and have gone through successively more complicated projects as they learn more and more skills. And sometimes they have to develop skills ahead of time because they're doing a project. So it's something that we take a lot of pride in, and we have a lot of fun with students, and we see them as research collaborators. So there's lots of opportunities here for that.
Great.
So while we're still talking about research, we also try to encourage students who are really interested in doing research to, at some point in their careers, do some research at a larger institution, right? And so there are programs called Research Experiences for Undergraduates that allow students to go to a large school like Purdue, University of Illinois, and see what a real research school is like, because they will have a lot more equipment, a lot of different equipment, although most of them undergraduates are not allowed to use. but we do want it's good for students to experience what an actual research institution looks like. But we do think that when they come back here and do research at Rose-Hulman, we can provide them a really great experience.
Those experiences are generally summer experiences. Right. So students would go to University of Illinois or to Purdue or wherever. They go all over the country and spend 12 weeks, as part of a research team.
Casey wants to know if the biomedical engineering program is accredited by ABET. Also, what are some of the most popular internships for BE majors?
Okay, so first I'll take the accreditation question.
Well, that's the easy one.
Yes, we are accredited by ABET. We've been accredited by ABET for 7 years now. We just had our reaccreditation in 2018. So yes, we are accredited, and that's been a really good process for us. I'll let you take the internship question.
So our students have had all sorts of different internships, but if I had to sort of describe the most typical situation, they are mostly going to work for medical device companies. So it turns out that Indiana is really sort of a center for a lot of the medical device industry. Of all places, the orthopedic implant industry is centered in Warsaw, Indiana, in northern Indiana, about 3 hours from here. So we have lots and lots of students who work for Zimmer Biomet, is the behemoth. That's the big company there. We've had students go to work for Stryker, which is based in Michigan. And then we also have very close to campus, within an hour from here, we have both Cook Incorporated in Bloomington, and Boston Scientific has a facility in Spencer, Indiana. And of course, Boston Scientific is a national or a multinational company. And so we've also had students work for Boston Scientific in Minnesota and in California. But the medical device industry is really the most common place. That's sort of the first go-to internship for our students.
Okay. Ashley would like to know what kind of crossover is there between biomedical and mechanical engineering programs at Rose? And is it common for students to double major in these two fields, or major in one and pursue a minor in the other?
So, so there's a lot of crossover between biomedical engineering and mechanical engineering. We have students often cross over to do research. We have mechanical students doing research in biomed. We have biomeds doing research in mechanical. We have if you look at senior design projects, oftentimes it's hard to tell the difference whether a senior design project is biomed or mechanical. We have had students double major in both. We've had many students graduate with double majors in either. So when you do a double major at Rose-Hulman, you choose a first major and a second major. We've had people go both ways: biomed first and mechanical second, mechanical first, biomed second. I think one advantage here at Rose is that we have very personalized advising, and so if somebody wants to do that, your advisor and I will work closely to try to make sure that happens. Yeah, so there's a tremendous amount of crossover. In fact,
I think so. That has absolutely been true historically, and there are a lot of foundational courses that are common to the two majors. So of course, all of the math is the same, the physics is the same, and there are a lot of freshman and sophomore courses that are common between the two majors. I think we have to say though that in the last year in our department, we've undergone a major curriculum revision that we're really, really excited about. And sort of the driving force behind that curriculum revision is we wanted to really distinguish the biomedical engineering major from other majors. There are things about biomedical engineering that are different from mechanical engineering, different from electrical engineering, and we wanted our curriculum to reflect that. So I think it will probably be a little bit harder than it has been in the past for a student to double major in mechanical engineering and biomedical engineering. But I think, as I've said, there's a fair bit of crossover, so you'll certainly get the flavor of both, whichever major well, you don't necessarily get the flavor of biomed if you major in ME, but you'll get the flavor of ME if you major in biomed. And I think it is still possible to get a minor in mechanical engineering if you have a major in biomed.
Quinn would like to know if biomedical engineering would help with medical school.
So the answer is yes. I mean, we have students that are interested in medical school can choose lots of different majors at Rose-Hulman. Some of them choose biomedical engineering, and it seems to work pretty well. We have defined a track for pre-med majors in biomedical engineering, and I think, and so we were able to get students through and meet all the requirements for biomed meet all the requirements for med school through the biomed program. I think it prepares you really well in a lot of ways. I think when we talk to students that have gone on to med school from the biomed program, lots of them say, well, it wasn't harder than undergrad. I mean, it was, I was used to working that hard, so it really wasn't that bad a transition. The learning is a little bit different in med school than it is in engineering school. But what our students really get out of the biomedical engineering program is the ability to do analysis, the ability to really critically think about decision-making processes and how you do that, which is important in medical school. And they also have a background in physiology and biology, which gives them a leg up on some other engineering majors as they enter med school as well.
I think for most engineering majors, whether it's at Rose-Hulman or elsewhere, they're pretty rigid. And when they're ABET accredited, there is a long list of things that we have to deliver in order for you to, to be a creditable engineer when you graduate. And so there's not a lot of wiggle room to add additional courses. Having said that, it is possible to do it, as Dr. Ahmed was saying. In the curriculum revision that I was just talking about, one of the things that we really tried to incorporate was an ability for students to take some ownership of their curriculum and to tailor it to their specific interests and needs. And so we carved out, and it was hard to do, but we carved out a sequence of 6 courses that are available to students to customize. And so a student who is interested in medical school can then use not all 6, but some of those 6 courses to fulfill some of the requirements for medical school. So I think we've, in the last year with this revision, I think we've made it a little bit easier for the biomed students to satisfy those pre-med requirements.
Great. Camille asks, how does your BE program incorporate other areas of study? Is interdisciplinary study encouraged?
Yeah, so one of the things Dr. Buckley was just talking about is that we hope our students take those 6 courses. We call it an AIM. We call it an Advanced Individualized Mission. And so we hope that students find something that they're really passionate about and use those courses to pursue that. Now, maybe that's part of biomedical engineering. Maybe that's something completely different. Maybe it's European civilization or whatever you're really excited about. We want students to be able to sort of pursue that and incorporate that in part of their studies. Biomedical engineering is almost by definition an interdisciplinary major.
That's what I was going to say. It's funny that we both paused at this question because I don't think of us as intentionally cultivating interdisciplinary work, and it's because biomedical engineering is by its nature multidisciplinary. So I think if you wanted to avoid multidisciplinary work, biomedical engineering would not be the field for you.
It's interesting though, when you look around the institute, there are people that do biomedical work in chemical engineering and in mechanical engineering and in electrical engineering. So we have lots of collaborators in other areas, and we allow students to sort of work back and forth. And so, yeah, I would say that we're quite interdisciplinary, but that's almost like the nature
by definition. Yeah.
Clara wants to know if you would consider Rose's BE program to be more hands-on or theory-based.
That was also a big goal of this curriculum revision. I mean, all the departments, all of the programs at Rose-Hulman do have a hands-on emphasis. It's one of the advantages of being at a smaller place. But even within this culture, we wanted more of that. And so one of the other defining features of this revision is that there is a 12-course sequence. So that's one course every quarter in the whole 4 years. That is a BE design-based course. And those courses are absolutely meant to be hands-on. They all have a lab component. And so from the very first term, the fall of the freshman year, you're in a BE course that has a lab doing stuff. And so I'm glad you asked that question, because it was really one of the things that we were paying special attention to when we did that curriculum revision.
Ashley would like to know, or she says that I've taken engineering courses, biology, chemistry, physics, anatomy, and physiology in high school. Does this effectively convey my interest in BE?
Yes, it does.
You have all the bases covered,
yeah.
yes.
I thought that would be an easy one.
So in general, though, we are not. I mean, I think it's great that you've shown that interest, and I think it gives you a leg up when you get here into the program, and would help help you move forward faster. But in general, we're expecting students to come in with the standard high school prep, having had calculus.
Not required, but helps.
Yeah, and so we can work with anybody. I don't think that you should feel like if you haven't had that kind of a background that you're not going to be able to be successful here. I think the expectation is you're going to come in with a good, solid high school background, and we will fill in whatever you need.
Hannah would like to know, have there been any students go into pharmacy school with a BE degree?
I think there have. I can't remember exactly who it was. Our health professions advisor is Dr. Bill Weiner, and we're going to include his information in the chat here. So he would be able to answer that question directly. But certainly, that's something that we would expect students to be able to do. I think there's at least one student that has gone there, but I can't remember exactly who that was.
And again, with this aim that we're talking about, this block of 6 courses, if pharmacy is your mission, then you have that opportunity to use those slots in the curriculum to fill in some of the requirements that you would need to get into pharmacy school.
I think this may fit into the AIM conversation as well. Sam asks, can you do a neuroscience concentration in biomedical engineering or biology?
So we don't offer a formal neuroscience concentration, but if you look at if you look at the courses we offer, we teach. So all biomeds are required to take one course in neuromuscular physiology, and then we offer electives. So Dr. Chu offers an elective in biomedical signal processing, which is important in neuroprosthetics. He offers an elective in brain-machine interfaces, which requires a lot of ECG stuff. I offer an elective in neuroprosthetics, which has a lot of brain stuff in it. So we have a lot of, and of course there are research opportunities in that area as well. So somebody that's interested in neuroscience, we have a lot to offer, but we do not have a formal neuroscience concentration.
Would be a build your own situation.
Yeah. And again, that's something that we keep talking about, the AIM, which we're really excited about. And one of the things you can do, because we also have psychology courses and other courses around, and electrical engineering. The next quarter, they're teaching an introduction to neural networks course. Mike McInerney and the physics department is teaching that course. So that's the kind of thing where the AIM is perfect. You can choose 6 courses that look at neuroscience from lots of different ways.
So that our current sophomores are the first class who are going through this new curriculum. And it will be this year that they will be asked to develop their AIM, develop a plan for their AIM. And I'm really looking forward to seeing what they come up with.
So What sets Rose-Hulman's BE program apart from other colleges?
Well, I'm sorry. Go ahead.
I mean, to me, I think it's this hands-on component. And while it has always been there, I think now with this curriculum revision, it's even more out front. It's a relatively small department. We have approximately 40 to 50 students in each of the 4 classes. And so it's a very tight-knit department. Our students kind of march through the curriculum together, and so they wind up being very bonded to each other. We get to know them really well. And especially when you're in those courses with students where it's not, you standing in front of the room just jabbering at them. When you're in lab, it's much more, informal and casual, and you really develop a relationship with the students that way. And so, I mean, I'm a little bit biased, I guess, but I feel like our department has a really good vibe that does derive to a great degree from that emphasis on the hands-on component.
I would sort of add to that we have, it's the same as all across Rose-Hulman. We are an undergraduate-centered program, right? So we have teachers who are here who have made a decision at some point to come and teach undergraduates, and that's what they're passionate about. And it's a little, we're kind of obsessed about that. All of our conversations outside of classroom, many of them are about students and how do we do a better job teaching students. I think that sort of gives us a fundamentally different type of undergraduate experience than you would get in a large school. And so I think some of it depends on what you're looking for as an experience, as a college experience. But we think that we really get to know our students very well. I mean, I think we could list, we probably know most of the students, what they're doing right now and where they are, that have graduated.
Or what they should be doing
anyway. And so I think it's a place where you get to know faculty very well. You get to know the other students, like Dr. Buckley said, we have about 40 students in a year, which translates to 2 sections of classes going all the way through, especially now when they're doing 12 quarters worth of design work. It really is a strong sense of community. I just love being part of the department, both in terms of working with faculty and working with our students. I think it's just a great place to be.
It's great. And now, those of you on the chat, I'll draw your attention to the chat box where Dr. Weiner's contact information has been put in. So that's available there for you. I do have one question left that I saw early on. It was one of the first questions, and I like it because it's easy and it's positive. It's from Natalie. She says, hello, and hope you're all staying positive and testing negative. We'd like to know what career fairs are like on campus, and that's the final question of the night.
You should go to the website, and I know that this is featured on our website every year when we have a career fair, because it is a spectacle. Our graduates, not only in biomedical engineering and all the programs at Rose-Hulman, are in high demand. So in a normal non-COVID year, the career fairs take place in the field house in our sports and recreation center, and there are booths set up for hundreds of companies, and our students all turn out in their suits and their ties and their pumps, and it's a sight to behold. In the spring, and we have one career fair each quarter. Starting last spring, of course, we could not do that in person, and so the career fairs have been held virtually, both in the spring and then again this quarter. And I don't know the mechanics exactly of how that works, but students submit their resume in advance, and then there's an opportunity to talk with representatives from the companies, sort of in the same way that you do when you're there in person, but of course you're doing that virtually. So the resumes are shared electronically in advance, and then students express interest in a particular company, and representatives from that company can sort of tap you for a conversation.
So the Career Services Office has has assigned a single person to work with all of our biomedical engineering majors. Pam Tabor is her name. And so they're constantly getting emails from her. Every time she gets an opportunity, she sends them out. She will sit down with them and help them design a search plan. She will work with them on resumes. She really helps our students quite a bit. And that starts freshman year. I mean, as soon as you reach out to her, she's responsive to that. The other thing that's interesting about biomed is that there's a lot of small biomedical engineering companies. So it's kind of hard for those small companies to get out to the career fair. And that makes biomed a little bit different from some of the other programs around here. But what's been great about career services is they've invested a lot in creating online access to a lot of these companies. Handshake is one of the platforms they use, but they also have several others where they work really hard to allow students to connect to these smaller companies that would maybe be hard to find without these tools. And so what we found is that students have been quite successful at getting internships, getting jobs through career services. They will also help if we have a good number of students who decide to go on to grad school after they come to Rose, and they will also help with that process as well. Although you can also get a lot of help from faculty who are well versed in what it takes to be successful in grad school.
I think with every passing year, as our graduates go out into industry and work in companies large and small, our reputation is growing. We have a large alumni network now in the medical device industry. And so there's lots of opportunity to make those Rose-Hulman connections. And those employers, once they get a taste of Rose-Hulman BE graduates, they frequently come looking for more.
It happens every year almost. I feel like somebody we just said. So our footprint when we first started the program 20 years ago, our footprint was really small. We were getting people in like Warsaw, Indiana, and Chicago, maybe. Then we got some alumni in Minnesota, and so then we had a lot of students going to Minnesota. Now we have alumni in California, and so they're pulling students in, and they come back. They will come back. So, for instance, Kelly Greenberg, who's not Kelly Greenberg anymore, but she went to Minnesota to work for a company called Minutronics, and she has come back. And every year they snag one of our best students, and so they must have 4 or 5 of them there now.
They had 3 interns this summer.
Oh, really?
Yeah.
So,
thank you very much for all of your insights this evening, and thank you all for joining us. Next week we're going to have representatives from the engineering, design, and humanities, social sciences, and the arts. So everybody have a wonderful evening, and thank you again for joining us.
Thanks for the questions.
Thanks.